Top 10 Misconceptions and Misunderstood Concepts in Special Relativity. Number 13. A moving observer experiences time dilation. So, you think you really understand special relativity? Then watch this short video on time dilation and you will likely change your mind. And there are 12 more videos on various misconceptions on special relativity. Coming soon. 13 Misconceptions and Misunderstood Concepts in Special Relativity. Special relativity is one of the most misunderstood theories in physics. There are a number of pervasive misconceptions regarding various essential concepts in the special theory of relativity. It's somewhat paradoxical, considering that it is one of the simplest and most elegant theories in physics, and it has been around for over 100 years now. We will go through a dozen or so common misconceptions in this new series. One thing to note is that most of the commonly held misconceptions are not entirely wrong as in black and white. Rather, their errors are subtle, although they can be still profound. In many cases, the ideas held by many people are also so vague that it is often hard to tell what exactly their misconceptions are. A moving observer experiences slower time. Misconception number 13 of 10. So what do you think this statement means? The honor of being the first on our list goes to time dilation. It is one of the most familiar ideas to anyone who knows a bit of relativity. And yet, this is one of the most misunderstood concepts in special relativity. Related misconceptions and other possibly faulty ideas. In addition to a moving observer experiences time dilation. Time slows down for a moving clock or moving observer. A moving clock runs more slowly. Time dilation can only be seen when two clocks are compared at the same place, as in the twin paradox. Time slows down only for clocks in an accelerated motion. Real time dilation happens only in general relativity. If you can travel at the speed of light, time will stop. Time is relative. Yes, even this. We are not going to address all these misconceptions today. They are all, in some way, related, but there are some subtle differences among them as well. One of the main causes of misunderstanding is that we mix some related but distinct concepts. By the way, text that is so small that you cannot read on these slides is not intended to be read. Doesn't time of a moving clock slow down? Of course it does. That is what time dilation is all about, isn't it? So why is this a misconception? What is the misconception? What does it mean to say, time slows down for a moving clock? When people say that time slows down for a moving clock, what do they usually mean? We all have clocks and some wear watches, and we all have a clear sense of time with respect to ourselves. A clock runs at a certain standard rate. Now, if people say a moving clock runs more slowly or something similar, then it usually means that if you move, e.g., at a fast speed, v, close to c, your time will slow down. All these statements like a moving observer experiences slower time, and time will slow down to a standstill if you move closer to the speed of light, usually have similar connotations, with varying degrees of ambiguity. Is that how you understand time dilation? Time runs more slowly for a fast-moving observer? If that is how you understand the concept of time in special relativity, then you are not understanding the special theory of relativity correctly. This is one of the most common misconceptions in special relativity. Here's the truth. A moving observer does not experience slower time. It's not about the language. We are not saying that the way we express certain concepts in special relativity is wrong. We are examining the ideas that are hidden behind those expressions. Clock versus time. What is time? We cannot see time. We cannot hear time. We cannot feel time. So what is time? Time is what is measured by a clock. Then what is a clock? A clock is a device that measures time. So which comes first? According to Einstein, The clock is more fundamental than time. Clearly, what we present here is our subjective opinion, to a certain extent. Take it with a grain of salt. Einstein's time. How is time defined in special relativity? One of the most important discoveries by Einstein was the fact that time was relative to an observer, or a reference frame at least, according to his theory of relativity. Einstein defines time by first placing clocks at various points on a given inertial reference frame, synchronizing those clocks relative to the given inertial reference frame, and using those clocks to assign time to an event. Time defined this way can then be used as the fourth dimension, a la Minkowski. So what does this all mean? So can you see time? Clocks are continuously distributed and synchronized in the 3D space according to Einstein's scheme. Clocks run at a certain rate over time at each point in the given inertial reference frame, IRF. In Minkowski's formalism, the clocks are static, and they occupy points in the 3+1 dim space, IRF. What is time dilation? Time dilation means that time with respect to a moving clock slows down relative to an observer. There are two circumstances in which time slows down in relativity. A fast-moving clock runs more slowly and a clock runs slower in the strong gravitational field. Both relative to an inertial observer. We will only consider time dilation due to a fast motion in this series, which is the subject of special relativity. The paradox of time dilation. Hence, if you don't understand special relativity correctly, you may see the following scenario as a paradox. Suppose that Alice and Bob are in a relative motion to each other. Then, Alice says to Bob, "Your time runs more slowly. Since you are moving with respect to me." Bob to Alice, "No, your time runs more slowly. Since it is you that are moving with respect to me." First of all, these assertions by Alice and Bob are both rather ambiguous as they are stated, and they are more than likely the reflections of their misunderstanding of special relativity. Sloppy thinking leads to sloppy language. Sloppy language leads to sloppy understanding. Sloppy understanding leads to sloppy physics. Time dilation in special relativity means a rather specific thing. It does not mean that your time slows down if you move at a fast speed. The fountain of time. Let's start from the absolute basics. The law of the constant flow of time. Time flows at the same rate for all of us, regardless of how we move, and regardless of how we measure time. But, time is relative. No? What exactly does it mean then by time is relative? Time is defined, measured, and used relative to a particular inertial reference frame. That is, time has no physical meaning unless it is specified with respect to a specific inertial observer. My own time with respect to my reference frame. All clocks are synchronized at each moment in time t. Time flows vertically upward. Can you imagine an infinite number of clocks all over this coordinate system, which are all synchronized along the horizontal direction, and their time indications advance along the vertical direction? Somebody else's time with respect to my reference frame. Bob's time flows more slowly when viewed by Alice. Alice's time flows more slowly when viewed by Bob. That is what we mean by time is relative in the context of special relativity. Timetable. To summarize, suppose that Alice and Bob are in a relative motion with a constant relative speed. Then, Alice's clock and Bob's clock with respect to Alice IRF and Bob IRF. Time is relative to an inertial reference frame. Alice's time with respect to Alice's IRF and Bob's time with respect to Bob's IRF run exactly at the same rate. Bob's time with respect to Alice's IRF runs slower, compared to Alice's own time with respect to Alice's IRF. Alice's time with respect to Bob's IRF runs slower. The recap of what we have learned for the last 10 minutes of our life. Time flows at exactly the same rate for each of us. Nobody knows why. But This principle seems more fundamental than the principle of relativity. Or, we can treat this principle as the law of nature. Then, this is also part of the special principle of relativity, which states that all laws of nature should be the same for all inertial observers. What's next? In the next few episodes, we will go through the most common misconceptions held by many people who are not really familiar with special relativity. In particular, in the next 2 episodes, we will address the following 2 concepts in special relativity, which are so fundamental and yet which are misunderstood by many people. Motion is relative and the speed of light is constant. Take-home questions. If you are interested, what does the statement "time is relative" mean to you? How can you verify or at least convince yourself that time runs at the same rate for all of us? Why do you care about special relativity? What do you think will be the top 10 misconceptions in our top 13 list? Please like and subscribe Nutty Physics.